Okay. Kabir, can you hear me? Please send me message. Okay, I think now okay, right? Okay, fine. Uh, the thermochemistry tutorial. Last week we already discussed all advanced calculations in maximum level, every types of calculations, exam asking, all types we discussed. Then today we're going to discuss exam questions, actually exam questions. Last week my tutorial already completed, our class tutorial. This is A-level questions, past paper questions. Okay. Okay, before that, 2026, the new revision classes is starting from 6th, 7th of day after tomorrow. Not tomorrow, day after tomorrow, 7th of November. It is Friday. Fridays 8:30 morning. Morning. It is a school. There is no school this month, no? No schools. Then you can, yeah, school. A lot of students are private students. Therefore, no problem. We can conduct the revision class only this week in the morning time. If there are any issue, we can get into evening time if it is required. Okay. Okay. In this Friday, we're going to start the biomolecule lesson. Very important biomolecule lesson. Biomolecule lesson. And tomorrow, I hope to post your tute packs. Revision tute pack. Revision tute pack. Then you will have biomolecule lesson. Biomolecule lesson tute. It is a full tute. This is a tute. Yes, I have tute for this. Just like a book. Okay, it is not the. It is only in a page. You have colorful cover page, and this is a tute and biomolecule tute, and you have 4 revision papers. First month revision papers that we called as daily refresh. Daily refresh paper 1, 2, 3, 4, and this is your first tute pack. I'll post your first tute pack tomorrow. Then for first day it is introduction, no need tute pack. For the second day, next week revision class, you need the tute pack. Therefore, don't worry. Within 3 to 4 days, you will have your tute pack. It will receive in post service. Okay, post service. Not courier, post service. Okay. Okay, let's start the tutorial. Question number 1. It is 2015 MCQ question. 2015 MCQ question. Only one MCQ question from thermochemistry. Okay, let's see. The amount of heat energy generated is 604 kilojoule when 12 gram of ethylene. Ethylene mean what? ethylene, I think you know, to ripening of fruits, banana, papaya, ripening of fruit, we use ethylene, right? Ethylene gas important for the ripening of fruit, ripening of fruits, fruit ripening. Okay, that's the purpose of this ethylene. Ethylene gas is combusted. 12 gram of ethylene gas combusted, then 604 kilojoule is generated. Okay, understand. First, you need to understand the molar mass of the ethylene. C2H4 mean ethylene. The molar mass of the ethylene is given. It is 28 GMOL minus 1, 28 grams per mole. 28 grams per mole. The balance equation for the ethylene combustion is given below. Ethylene combustion balance equation given below. This is a balance equation. I will note down. I'll get this balance equation into our board. C2H4. C2H4 react with oxygen. React with oxygen. Then what is the produced product? Carbon dioxide and water. CO2 and H2O is produced. CO2 and H2O is produced. Ethylene react with combustion mean burning. Burning mean react with oxygen. Very simple. React with oxygen. Okay, now in this question, already balanced equation given. Already balanced equation given. If it is unbalanced equation given, what is your first step? What is your first step, Rehla? Balance the given chemical equation, right? In the lesson, in the tude, in the note I given in the first day of heat of reaction explanations, your first step is balance the given chemical equation. I think you can remember. Balance the given chemical equation. Okay, how to balance this equation? Okay, think they given the equation like this in this form without balancing. Without balancing. Then how we balance this? Okay, I'm going to start carbon, 2 carbons in left side, only 1 carbons in right side. 4 hydrogens in left side, 2 hydrogens in right side. 2 oxygen and 2 oxygen. Therefore, oxygen already balanced. Sorry, oxygen 3. Sorry, oxygen 3. Oxygen also not balanced. Therefore, we have to balance all these molecules. All these molecules. Okay, now I am going to add. Okay, I am going to remember if there are any odd number of any molecule, odd number. Now oxygen is in right side, oxygen odd number, right? I think you got odd number. It is 3. Okay, first of all, you need to balance oxygen. That's a method. Okay, understand this balancing method. First, you need to balance the oxygen. Okay, now I am going to, because with this odd number, we cannot if you follow any method, you can't balance without balancing this, without convert this odd number into even number. Understand? Okay, now I am going to remove this odd number. Now, if I add 2, then oxygen number is increased to 4. 2 plus 2. 2 plus 2. Okay, then oxygen 4. Oxygen 4. Now carbon, this side 2, this side the number of carbon in this side 1, this side 2. I'm going to convert it into 2. I'm going to convert it to 2. Then oxygen number again changing. Then I keep this empty. Carbon dioxide. Then carbon number 2, 2 correct. Oxygen also 2, 2. Then oxygen is increasing, no problem. Hydrogen 4. hydrogen 4. Okay. Hydrogen 4, hydrogen 4. Now we can balance oxygen amount, right? Oxygen 4 and it is 6. Then we can add 6. Okay, that's the balance equation. That's the balance equation. Okay, then let's take. Yes, I'm correct, right? I'm correct. This is a given equation, balance chemical equation. Without getting this equation, I balance, and I think you got the balancing methods. Last week also I explained a lot of equations, how to balance and how to find the heat of reactions. Okay, that's the method. I got the balancing method. First of all, you need to balance the oxygen. Oh, any method you can start, but finally you should balance all this left side to right side. Reactant to product need to balance. I got the point. Rehla? Balancing okay? Okay. Now don't take more time because it is MCQ question. That's why I'm doing rapid. Okay. The equation is given. The question asks the heat of reaction of ethylene combustion is. Heat of reaction of ethylene combustion. Ethylene combustion. Okay. Remember, if any material, if any matter reacted with oxygen reacted with oxygen means burning reactions, oxygen always excess. Oxygen always excess. Because oxygen not limited. If it is oxygen limited, it is not burning. The question given fully burning, then it is oxygen is excess. Then only you need to consider about ethylene. Only you need to consider about ethylene. Okay, see. Okay, the ethylene molar mass is given. Ethylene molar mass is given. Molar mass of ethylene 28 GMOL minus 1. GMOL minus 1. Okay, now I'm going to follow my same steps. Last week discussed the heat of reaction. My first step, balance the given chemical equation. The second step, calculate the amount of moles added to the reactant. Added to the reaction. Okay, how to find this C2H4? That means ethylene moles, number of moles. How to find this? Ethylene number of moles. How to find this? I got this, Habir. I got ethylene number of moles. The molar mass is given. Easy. I found, Habib, Fatima, I found the number of moles in ethylene reacted ethylene number of moles. Answer. Dihini? Okay. I think you can remember. Then what is the number of moles? N equal mass over molar mass. I think you can remember. Okay, good. Mass over molar mass. Okay, what is the mass? How many? What is the mass of ethylene? It is 12 gram. 12 gram. 12 gram divided by molar mass. Molar mass 28 GMOL L minus 1. 28 GMOL minus 1. Okay. Now 12 over 28. What is this? Then G to G cancel out. G to G cancel out. 12 over 28. Then moles come to upward. Then it is minus 1 remove. Then it is more. Moles. Okay. 12 over 28. What is the answer? Dehini? 12 over 28. 0.428 moles. Very good. 0.428 moles. 0.428 moles. 0.428 moles. Okay, now I found ethylene number of moles added. Okay, how in the it is second step. In third step, this is my first step. I am again revising last week lesson. Last week the steps. Balance the given chemical equation. Calculate the number of moles added to the reaction. Calculate the number of moles added to the reaction. Then what is the third step? Calculate the actually reacted number of moles. Okay. How about the actually reacted number of moles? Actually reacted number of moles. Ethylene stoichiometric ratio 1 to 3 now. 1 to 3 is the stoichiometric ratio. 1 to 3 is the stoichiometric ratio. Then actually reacted ethylene number of moles. Reacted. Okay. Actually reacted. Now the added amount of moles we found. The added number of moles it is 0.428. Now I want to get ethylene reacted number of moles. What is the value? No need to consider, right? No need to consider this stoichiometric ratio or anything because always oxygen is excess. Oxygen excess now. Oxygen concentration is excess. To react this much of ethylene, this ethylene moles, excess required amount of oxygen is supplied. That's the meaning of oxygen excess. Then the reacted number of moles also 0.428 moles. No need to consider. Okay, now the heat of reaction you already know. Before heat of reaction, the quantity of heat given in the question, the quantity of heat given in the question, the heat of reaction, the quantity of heat divided by number of moles. I told the quantity of the heat of reaction mean the amount of heat absorbed or released while reacting 1 mole of reactant. 1 mole of reactant, that's the meaning. Then reacting 1 mole of reactants the amount of heat released, because it is exothermic reaction, because it is combustion reaction, exothermic reaction, then this reaction, ethylene combustion heat of reaction mean what? While reacting 1 moles of ethylene, how much how about the heat energy released to the environment? Okay, what is the quantity? Okay, what's the quantity of the heat energy released to the environment? Okay, now the quantity of heat given, the Q value is 604 kilojoule. 604 kilojoule. 604 kilojoule. The number of moles. What is the number of moles? Number of moles I found 0.428 mole. Okay, what is the value? What's the value? Tehla? 604 divided by 0.428. Yeah, approximately this is the answer. It is not given the correct one. Yeah, in exam, this is the answer. They given marks for this answer, approximate answer. I got or any doubt you can ask. The same thing we did in same as last week calculations. Any doubt you can ask. Any problem? Please ask quickly. Okay, are you clear? Habib, Rehlan, clear or no? Rehlan, please send Amina, Udanya, clear or no? Do I need to explain again? Okay, I will explain. I will revise again the steps of heat of reaction calculations. First of all, you need to balance the given chemical equation. This question, the given equation already balanced. Therefore, you don't need to worry about this. Okay, it is already balanced, but I explained how to balance this equation. Okay, in the second step, I found how amount of moles, ethylene moles added to this reaction. Okay, then the added ethylene amount is 0.428. I found the number of moles equal mass over molar mass. The molar mass is given in the question. The molar mass is given in the question. Okay, then I found the actually reacted number of ethylene. Then ethylene combustion mean oxygen cannot be limited. If it is oxygen limited, this much of ethylene cannot be combust, right? Cannot be combust. cannot be burned. Therefore, ethylene is always excess. Sorry, oxygen is always excess. Therefore, we don't need to consider about oxygen. I only consider ethylene. I only consider ethylene. Then the heat of reaction of ethylene, C2H4 is this value. It is not the full. It is not for oxygen. Okay, the heat of reaction for ethylene is this value. The question asks, see, the question asks the heat of reaction for ethylene combustion, not for oxygen. Okay, oxygen we don't need. Ethylene combustion. Amina, Harnil. Okay, let's go to the question number 2. An inflated balloon with air is expanded due to heat. An inflated balloon with air is expanded due to heat of sunlight. Heat of sunlight. Air expanded due to heat of sunlight. If the heat absorbed into the balloon is 450 joules. 450 joules absorbed into the balloon. Absorbed into the balloon. And the work done by the balloon is 127 joules. Okay, the work done by the balloon. The words here important. Work done by the balloon. Work done by the balloon. Okay. What is the internal energy difference of the balloon? What is the internal energy difference of the balloon? Okay, see this. Okay, this is a balloon. Think this is a balloon. This is a balloon. Okay, now the balloon mean think it is as a system or normally this is a whatever object balloon. Okay, balloon. Okay, now the question given 450 joules absorbed to the balloon from environment. 450 joules absorbed to the balloon. 450 joules absorbed to the balloon. And the work done by the balloon. Work done by the balloon. What's the meaning? The balloon is doing work of 127. Then what happened? The balloon doing work, whatever object doing work, what happened? Energy amount, energy loss or energy increase. Now you while doing working, the energy decreasing or increasing? What happened? Simply understand. You're doing some work, then your energy level increasing or decreasing? It is decreasing, no? Then balloon work, doing some work by the balloon, then 127 joule is loss. That's the energy loss. When 127 joule work doing by the balloon, 127 joule is lost. That's the energy loss. Now, what is the internal energy difference of the balloon? Okay, what is the internal energy difference of the balloon? Okay. Okay, you can think very simply, you can understand that like this. Okay, think initially I have inside the balloon, think initially 100 joule, the energy level of the balloon inside the balloon, initially it is 100 joule. Okay, now 450 joules absorbed by the balloon, then what happened to the energy level? It is increased up to 550 joules, right? It is increased up to 550 joules. Now 127 joules lost again. Then what is the remaining amount? What's the remaining amount? 550 minus 127. Okay, what is that? 550 minus 127. What's the remaining amount? It is 423. 423 is the remaining amount. Okay, now the question asks internal energy difference of the balloon. Internal energy difference of the balloon. Okay, how to get the internal energy difference mean delta E. Internal energy difference mean delta E. What is the delta E mean? I told the delta E mean energy difference mean final energy level minus initial energy level. Final energy minus initial energy level. Final energy level minus initial energy level. Okay, what is final energy level now? Final energy level 423. 423 minus initially it is 100. Initially it is 100. Now it is plus 323 is the answer. Plus 223 is the answer number 3. Answer number 3. Okay, this 100 I got as example. Okay, if you want, you can think initially it is 0. Okay, think initially inside the balloon, initially energy level is 0. How is 0? Initially it has only 0 energy. Then 450 joules absorbing the energy level increased to 450. Now initially 0 joule. Absorb 450, it is increased to 450 joules. Then the balloon doing work of 127 joule. Then the 127 joules lost. 127 joules lost from the balloon. Then what is the remaining amount? The remaining amount to 323 joules. It is a plus value. That's the remaining amount. That's the remaining amount. Okay, now delta E, what is the delta E? If I got 0, the final energy level 323. Initially it is 0. It is 323 joules. I think you got full idea. Harne? Rehla? Amina? Understood? Fatima? Always remember, when any object doing work, energy loss always. ඕනම object එකක් work එකක් කරද්දී doing work, always the energy inside energy loss. If any work doing on the object, think the question given like this. Example, okay, think this is a balloon. 100 joules doing on the balloon. Then energy level increasing or decreasing? Now initially it has inside the balloon 50 joules. 100 joules of works doing on the balloon. Then energy level increasing or decreasing? What you mean? Energy level increasing or decreasing? 100 joule of work doing on the balloon. 100 joules work doing on the balloon. Then what happened to the energy level? When any work doing on any object, the energy level is increasing. If this object doing any work, then energy level is decreased. I think you got the point. Harned, Rehalan, you got the difference? You know, if you understood the in work definition, what's the meaning of work? Energy transformation from one object to another object for any moment, the energy transformation that we called as work. Then the work equal to any object doing any work doing on the balloon, the energy level is increasing. Any work doing by the balloon, the energy level is decreasing. Energy level is decreasing. Okay. Which statement is correct regarding thermodynamic system and process? All non-process are exothermic. Correct regarding all non-process are exothermic. Is it correct? No, no. All non-process are exothermic or endothermic. Both exothermic or endothermic. Not only exothermic. Not only exothermic. No. Boundary of a system must be visible to the naked eye. Correct or wrong? In the lesson we discussed. Theory part. Is it must be visible to the naked eye? No, I told the boundary of a system. The boundary mean, I think you can remember. If we think this is a system, if it is system, this is a system. The system mean any area selected for a study in the universe, from the universe, that we called as system. Then instead of except system, other all surrounding parts we called as environment. And system and environment separate by the boundary. System boundary. System and environment separate by the system boundary. System boundary. System and environment separate by the system boundary. System and environment separate by the system boundary. Then boundary of a system, I told in the lesson, the system boundary can be physical one or imaginary one. It is possible to visible in our naked eye or not. It is imaginary, like satellite or whatever imaginary one. Okay, therefore it is wrong, completely wrong. All real systems are closed systems. No, all real systems can be open system, closed systems are and isolated systems also. Total energy of an isolated system can be changed. Total energy of an isolated system can be changed. The temperature difference can produce a heat flow. Yes, the temperature difference can produce heat flow. Always there. The fourth one, the total energy of an isolated system can be changed. Is it correct? Correct or wrong? It is. The fourth one also wrong. Why? Why it is wrong? Because isolated system mean, I think you can read the lesson theory part. Isolated system mean to the system boundary, energy or matter both cannot be exchanged. Both cannot be exchanged. then always in isolated system, the energy amount inside the energy amount, it is always fixed value because with the environment cannot be exchanged. Okay, therefore in the statement 4, the total energy of an isolated system can be changed. It is wrong. It cannot be changed. Go to final one. The temperature difference can be produced heat flow. Yes. The temperature difference always produce heat flow. Otherwise, if it is same temperature, not produce heat flow. Understood? It is 2020, 2016, 2 MCQ questions asked. 2016. 2015, only 1 MCQ question. Okay, let's move into 2017, also only 1 MCQ question. The reaction between an acid and a base can be shown in the following. Okay, acid-base reaction, it is, now you should know, acid-base reaction, initially, while you read this question, you should know, this is acid-base reaction. Acid-base reaction mean what? Exothermic or endothermic? Amina? Acid-base reactions are exothermic or endothermic? Sarmya? Acid-base reactions are endothermic or exothermic? Definitely, acid-base mean neutralization reactions. They are exothermic, definitely. And the how about the heat of reaction value? It is plus value or minus value? The heat of reaction value? Minus value. Very good. Always exothermic reactions. Acid-base reaction is, it is exothermic reaction. Due to that, the heat of reaction is minus value. Heat of reaction is minus value. I got this. Why it is given minus? Because it is combustion reaction in the first question. The ethylene combustion is an exothermic reaction. Why the heat of reaction is minus? I think you notice this. The reaction between an acid and a base can be shown follow. The amount of heat generated when 100 milliliter of HCl acid reacted with an excess amount. In the last week tutorial, in the final question, I explained excess amount of sodium hydroxide. Excess mean what's the meaning? Excess amount mean always sodium hydroxide not limited. Required amount we can supply. Always limited. What is limited? HCl is a limited one. I think you can remember last week final question we discussed. This type question fully discussed with all steps. Okay, then the amount of heat generated, 100 milliliter of HCl acid reacted with excess amount of sodium hydroxide is 5.57 kilojoule. 5.57 kilojoule. 5.57 kilojoule, that's the quantity of heat, Q. The concentration of HCl solution is asking. The concentration of HCl solution is asking, not heat of reaction. Okay, how to do this question? Okay, I got this answer or not? Who got this answer? Yeah, it's a good question. The concentration asking, but it is heat of reaction question. Got others? Only 2. Good. Concentration asking, but it is heat of reaction question. Okay. Now, You should have proper idea. You should have full idea. Okay, good. You should have full idea for this units. Now it is given 55.7 kilojoules per mole. Then what is this? What is the name of this for this reaction? This is the heat of reaction, right? It is given kilojoules per mole spin. To react 1 mole, the amount of heat exerted. The amount of heat is released. Okay, then 55. That is the heat of reaction. First of all, you should identify heat of reaction. Otherwise, you can't do this calculation. How you can identify this? By this unit, kilojoules per mole. Per 1 mole, how many kilojoule is released to the environment by this system, by this reaction? Okay, now, okay, the heat of reaction given, and the quantity of heat given. First of all, I can calculate the heat of reaction. The heat of reaction, quantity of heat divided by number of moles. Okay, the heat of reaction value is 55.7 kilojoule. Kilojoule mol minus 1 equal quantity of heat 5.57 kilojoule. 5.57 kilojoule divided by number of moles we don't know. Number of moles we can find by this equation. Okay, now I am going to calculate the number of moles by this equation. Number of moles N equal 5.57 divided by kilojoule divide by 55.7 kilojoule mol minus 1. I isolated the N. Isolate kargatta N. Okay, now what is this value? Kilojoule to kilojoule cancel out. You can understand kilojoule to kilojoule cancel out. 5.57 divided by 55.7. Then what is the answer? It is 0.1 moles, right? It is 0.1 moles. Good. N equal 0.1 moles. 0.1 moles. Is it answer? No, it is not the answer. It is not the answer. The question asks HCl, concentration of HCl solution. The concentration is asked. Okay, now the number of moles found, the reacted number of HCl, because sodium hydroxide excess means in the reaction all HCl reacting, right? You should have proper idea. Sodium hydroxide excess, therefore sodium hydroxide additionally available. Then while react limited HCl, then all HCl, all hydrochloric acid will be reacted. Therefore, no need to consider. That is the added HCl mole number of moles equal to the reacted number of moles. Then this is the added amount. Okay, now I am going to get the concentration equation. The concentration equal number of moles divided by volume. Number of moles divided by volume. Number of moles we found. Number of moles 0.1 moles. 0.1 moles divided by, how about the volume? The volume is given 100 milliliter. 100 milliliters, how you convert into cubic decimeters? The standard unit is cubic decimeters. See, the standard unit is cubic decimeter. 100 milliliters, sorry, not 1000, 100 milliliters, how you convert into cubic decimeter? Do you remember this unit conversions? This unit conversion is very important. I told 10 centimeter equal 1 cubic decimeter, right? Sorry, 1 decimeter. Then 10 to the power 3. 10 to the power 3, that's mean 10 centimeter into cube, that is 10, it is equal to 1 cubic decimeter. 1 cubic decimeter, the meaning is 1000 cubic centimeter. 1000 cubic centimeter equal to 1 cubic decimeter. 1 cubic decimeter mean always 1000 cubic decimeter. I think you can remember. Then this 1 cubic decimeter equal 1000 cubic centimeter mean always 1 liter. 1 liter. Or we can say 1000 milliliter equal to 1 cubic decimeter. Okay, this full unit conversion you should have remember. This is important. 1 liter equal 1 cubic decimeter and 1000 cubic centimeters equal to 1 cubic decimeter. Then 1 liter equal to 1 cubic decimeters mean if we convert this milliliter into liter, we can get the cubic decimeter value. I think you can get the idea. Okay, then 100 milliliter, I'm going to divide by 1000 to convert into liter. Then the liter amount equal to the cubic decimeter. Okay, then I'm going to convert into liter. It is 1000. 1000 divided by 1000. Okay, then 20 cancel out. 1 over 10. 1 over 10 it is 0 0.1. 0 0.10 divided by 0 0.1. It is, who correct this answer? Right, Sam? Dini correct. Others? Kabir, very good. Yes, very good. Amina correct. Okay, great. Rehlan, correct? Correct. Umindu. Not. Okay, okay. Are you understood now? Umindu. I got now. Okay. Are you understood now? Point it out. Okay. Try again the same questions. If there are mistake, try again. Okay. Consider the following statements. The reaction between vinegar and sodium hydroxide. Again, you have to think. The reaction between vinegar. Vinegar mean what? Vinegar mean acetic acid. Vinegar mean acetic acid. Vinegar mean acetic acid. Sodium hydroxide mean caustic soda. Sodium hydroxide mean caustic soda. We can discuss in future lessons. Solution. The reaction between vinegar and sodium hydroxide solution is acid-base reaction. Yes, the vinegar is a weak acid. Acetic acid is a not powerful acid. It is weak acid. The sodium hydroxide caustic soda is a powerful base. Then it is acid-base reaction. Perfect. Correct. Then acid-base reaction mean it is exothermic. No need to think, right? Acid-base reaction mean always exothermic. Acid-base reaction, it is exothermic. Endothermic reaction cannot be endothermic, right? Above correct statement would be A and B. Okay, see, they are exam questions, right? They are the exam questions, MCQ. This is one question, 1 marks in exam. If you do this question, you can get 1 marks from 100. Not too advanced, right? See, next question. It is 2018. Same. Heat can be defined as. The heat can be defined as temperature of the system. No. The heat is a energy type. The temperature is a measurement about heat energy. It is different. Total amount of energy of the system that we not called as heat, right? The total amount of energy that we called as total energy. The flow of heat between two systems, yeah, that we can consider, but we don't know. This type questions, you need to select most appropriate, most accurate answer. Amount of work done by system, that is not the heat. The amount of work done by a system, the amount of work done on a system, the amount of work done by a system, not both. It is not the same answer. Understand the difference? The amount of work done on a system. On a system, I explained here in the second question. The amount of work done on the system. Think this is the system. Amount of work done on the system. Then what happened? The energy level in the system is increasing. I got the point. Kabir, I got the point. The amount of work done on a system. The amount of work done on a system. Then what happened? The amount of the energy level of a system is increasing. The final point, the amount of work done by a system. Then what happened? This second question part, right? The second question, same as second question. The amount of work done by a system means the energy loss. Energy loss. Simply you can remember. How you can remember? Like, work something work doing by you, then energy level increasing or decreasing? Energy loss, right? Energy loss. Same. System also same. System also same. This one, how you can remember this one? if you get some food, if you work done on a system mean while you taking foods and different drinks, then what happened? Your energy level is increased. Okay, that's the method you can remember easy. Okay, if you understood this basic concept, actually these thermal chemistry, kinetic chemistry questions, sure marks in exam. Okay, 2018 questions very easy. The average distance between two close H2O molecule in ice, water at room temperature, and steam, ice, water at room temperature, and steam. L ice, L water, and L steam respectively. What is the correct relationship? Average distance among them. Average distance means the molecular distance. Okay, what is the answer? Send me the answer number. Udan, send the answer number. Okay, average distance means molecular distance. Molecular distance. Now you can. Rehlan, what is the answer? Molecular distance, ice, water, and steam. Ice mean solid. Ice means solid. Ice means solid. Liquid mean liquid. Steam mean gas, right? Dihini? Salmia? Very good. Now, what is the more distance one among liquid, gas, and solid? It is steam, right? Yes, the steam is a more distance. Yes, it is not equal. First one wrong. First one not equal. Uh, ice greater than water? No, no. Ice less than water. Ice distance less than water. Solid molecule distance less than liquid. Okay, therefore second one wrong. Third one, not anyone not equal. Cannot be equal. Final one, ice greater than water, incorrect. Now, steam greater than water, water greater than ice. Good. Answer number 4. Rehlan, understood or not? If doubt, please send me. It is simple. Yeah? Now you know. Ice mean solid. No? Ice mean solid. Water mean liquid. Steam mean gas. They are the physical state of matters. Physical states, main physical states of matters. Now solid mean their molecular structure is, they are tightly packed, right? They are no spaces actually. Very limited. The spaces very limited. That's a solid. That's a solid. That's a liquid. Liquid closely packed, but they have spaces than solids, right? I explained the lesson already. I explained in the lesson. That is a liquid. But if you got steam, steaming gases, they are freely, molecule freely available. They are for a lot of spaces. Then highly spaces, higher spaces, the greater spaces one is steam. See, it is not equal, not equal. One and third wrong. Now, okay. Okay now. Okay. 2020, 2020. Two questions. The amount of heat provided to system from the surrounding was 100 joule. The system retained 40 joule and rest was released to the surrounding. The total energy change in the universe is, okay, send your answers. It is same as 2020, but not 2020, 2015 question, not 2016 question equal to the 2020 question. Okay, therefore this past paper, practice past paper question, it is very important. In final few months, we are doing fully past papers. Okay, answers. Question number 8. Fatima? Oh. Okay. Can you hear me? We have to start everything again because any current failure, everything deleted. Lucky it is available. Okay. What is the answers? Question number 8. Habib, it is same as previous we discussed question. No, Habib wrong. Fatima, 4 or 2? What? The final. Okay. Yes. Good. The answer number 2, 0. How it is coming 0? No, Sarmi. Not 60. It is 0. Okay, it is very small point you need to understand. Okay, if you remember, I explained 3 categories, 3 parts in a system. All I told the selected area of to study, selected area for any study from the universe, that we called as a system. That we called as a system. That is a system. Okay, then what is the meaning of this? Is the universe. Think this is the universe. This is the universe. This is the universe. This is the universe. The full one is a universe. This is a universe. Except system, other all parts in the universe we called as environment or surrounding. Surrounding or environment. Surrounding. The system and surrounding separating by the system boundary. System boundary. Okay, now the question asks the amount of heat provided to a system from surrounding was 100 joule. 100 joule provide to the system, 100 joule absorb to the system from the surrounding. Think 100 joule absorb from the surrounding. And the system retained 40 joules and rest was released to the surrounding. That means 60 joules, 40 joule retained and 60 again released to the environment. 60 joules again released to the environment. 60 joule again released to the environment. Now what is asking? The total energy change, that means delta E in the universe. In the universe asking. Then if there are any energy change in the universe, if there are any energy change in the universe, I mean, if there are any energy change in universe, no any energy change in universe. Always we call inside the universe, the always energy is a constant value, energy fixed value. The energy fixed value. I in the lesson I explained energy is always moving a circular path, right? Circular path in the universe. Therefore, in universe, the energy always fixed constant value. Therefore, the inside universe energy change 0. Mukut velana. There is no changes. Understood, Kavi? Universe, not the question asks, not the, it is not asking about system. Okay, now if the question asks same as 2016, if they ask what is the energy change in system, what is the answer? What is the energy change in system? Rela. System again. What is the energy change in the system? Okay, same you can use. I think initially the energy level is 0 joule. Initial energy level is 0 joule. Okay, what's your answers? What your answers? The energy change in the system. Now the answer 0. Answer 0. Universe, there is no any energy change. Salmi, I got universe, there is no any energy change in the universe, but in system, what is energy change? Dini, what is energy change in system? Plus 40 or minus 40? Plus 40 or minus 4? Habib? Yes, very good. Okay, how you need to think? This is your thinking pattern. Okay, it is 0 joules. Initially, it is 0 joules. I assume, okay, I assume. Initially 0 joules, then 100 joule absorb what is the energy level? 100 joules. Inside the energy level 100 joule. Then 60 joule released to the environment, then remain only 40 joules. Finally remain 40 joules. Okay, now what is the energy difference between final energy minus initial energy? Energy difference delta E equal final energy minus initial energy. Then finally it is 40. Initially 0. 40 minus 0, it is plus 40. I think you got the full idea. 40 minus 0, it is plus 40. Okay, remember. Okay. In universe energy, 0. In universe, there is no any energy. Universe, there is no any energy. Okay, before that, are you free tomorrow? Are you free tomorrow 9 to 10? Are you all free? Because now 9 p.m. I need to start the final class for 25 students. Today we're doing now 8:30. Okay, let's try to complete MCQ part. Tomorrow, if we can get 1 hour, then we can finish this lesson, and next week we can start the kinetic chemistry new lesson. Okay, everyone okay? 9, 10, only 1 hour. 9 to 10. Okay, then today let's try to quickly complete our MCQ questions. If you want 2025 model paper structured part, we discuss in from 9 p.m. If you want, you can do. Okay, 20 second question. A chemical reaction occurs in a production process which involves a solid and liquid as raw materials. Solid and liquid as raw materials. Due to the exothermic nature of the reaction, the rate of chemical reaction is increased throughout the process. What is the best possible way to maintain the reaction at a constant rate? Okay, that one no don't need, because it is actually mistake. It is kinetic chemistry question. The rate of chemical reaction we mainly doing It is actually in common knowledge, general knowledge, you can get the answer. Now, understand the question. A chemical reaction occurs in a production process which involves for a solid and liquid as raw materials. Solid and liquid are the raw materials. Chemical reaction. Due to exothermic nature of the reaction, the rate of chemical reaction increase throughout the process. The rate of chemical reaction increase means the amount of heat production inside the chamber is increased inside the system. What is the best possible way to maintain the reaction at a constant rate? Okay, to maintain the reaction at constant rate, it is, and now you can understand this question, combining question, thermochemistry and kinetic chemistry combining question. Okay, heat in the reaction mixture, exothermic reaction, again we don't need to heat, right? It is already producing heat, therefore it is not the answer. Stirring the reaction mixture, yeah, stirring reaction mixture mean you can understand in next lesson. Stir karama, the reaction speed is increasing because mixing increasing. Therefore, again the heat producing is increasing. Therefore, we can't use this one. The introducing the solid at once to the liquid. Solid once to the liquid. Then what happened? Huge heat is produced at once. Then it is not recommended. It is not recommended. Introducing the liquid slowly into the solid. Yes, this is the recommended method. Slowly into the liquid. Crush the solid, then mix in the liquid. Crush. When crushing, their surface areas increasing. When crushed into small parts, then surface area increase that. Okay, this question full idea you can get after completing next lesson. Okay, the answer is 4. Who correct this question? Yeah, simply you can, if you think in practically, you can get the answer. Fatima, correct? Sarmia? No. Okay, no problem. After completing kinetic chemistry, you can get the full idea about what is the rate of chemical reaction, what are the factors affect to the rate of reaction, with these factors changes, what are the possible changes in reactions. If you have this idea, you can do this type, kinetic chemistry and thermochemistry mixed question, combining questions. Okay, this is thermochemistry question. When equal volume of 1 moles per cubic decimeter HCl and 1 moles per cubic decimeter sodium hydroxide. It is again exothermic, right? HCl and sodium hydroxide. Which graph correctly show the temperature variation of the mixture with time? Temperature variation of mixture with time. Okay, now it is exothermic reaction mean. Exothermic reaction. Now with time, what happened to temperature? Increasing or decreasing in exothermic reactions? Quickly send me. In exothermic reactions, with time, temperature increasing or decreasing? It is definitely increasing or decreasing. Yes, it is definitely increasing. Exothermic reaction, the surface temperature definitely increase. Okay, this is the time. This is the temperature. This is the temperature. Time and temperature. Right? Okay, now time and temperature. Now with time, now think this is the normal room temperature. This is the normal room temperature. Normal room temperature. The reaction is starting from normal room temperature. Okay, normal room temperature. Okay, think this is the starting point. Okay, with time, the temperature is gradually, rapidly increasing. Rapidly increasing the temperature. Then, after some time, the reaction will be completed. The reaction will be completed. Then what happened? It is taking constant temperature increasing, temperature level, and after that it is slowly cooling like this up to room temperature. It is not cool up to this level. -0 level, it is not cooling. Okay, this is a graph. This is a graph. This is a graph. This is a graph. Actually, it is slowly cooling. It takes more time. It is slowly cooling because due to the reaction, it is rapidly heating and slowly cooling. Slowly cooling. I think you got the point. Okay, this one, it is not correct because it is rapidly cooling. Cannot be rapidly cooling, right? Increase and constant rate. No, constant rate we can't maintain temperature. After completing the reaction, the temperature of the system decrease. Again come to the room temperature. Again come to the room temperature. It is slowly heating and rapidly cooling? No, no. Slowly heating and rapidly cooling? No. No. This one. Understood? Pehla? Salmia? Amina? Understood? Great. Okay. Again, same type question as question number 4, 2017. 2017 question again asked. All chemical reactions are not exothermic. All chemical reactions are single step reaction. No, all chemical reactions are not single step reaction. That one also you can understand in kinetic chemistry. All chemical reactions are always required catalyst. No, without catalyst, now normal reactions without catalyst they are doing. They are converting to products. They are producing product. All chemical reactions are endothermic and endothermic. No, all chemical reaction endothermic first term wrong. Then other part also. A single step reaction no. Reactant must reactant must collide with each other to produce product. That one also we doing in the kinetic chemistry. Therefore, don't put. Question number 12 from 2022 A level. What is the correct statement regarding the reaction between baking powder? Baking powder means sodium bicarbonate. Sodium bicarbonate. It is acid. No, no, it is not acid. Base. Sorry. It is base. Sodium bicarbonate. Baking powder and vinegar. It is base. Vinegar mean I told it is acidic acid. It is acid. Then it is acid-base reaction, neutralization reaction. That means it is exothermic. Okay. And open beaker. Open beaker means it is which type system? Amina? Open beaker means what is the system type? Is it open system or closed system or isolated system? Open or closed or isolated system? Udan open beaker. Yes, good. It is open system. Yes, the reaction is endothermic. Completely wrong. It is acid-base reaction. I told. See, very simple questions, right? This is an isolated system. No. It is open system. No. The system release energy to the surrounding Yeah, it is possible. Let's see. Surrounding provide matter to the system. Yes, that one was okay. Only energy passes through the border of the system? No. Only energy? No. Then the problem, you have two answers in this question. In exam, both answers correct. Don't forget. The system release energy to surrounding, correct, because it is open system. Surrounding provide matter to the system, that's also possible because it is open system. (2023). What is the correct statement regarding endothermic reaction? See, very simple questions. Endothermic reaction. Endothermic reaction. A single step reactions are endothermic. We can't say like this. Single step reaction mean normal direct reaction. They can be exothermic or endothermic, both. Okay. All multi-step reactions are endothermic. We can't say like this. All multi-step reaction also endothermic or exothermic, both. The energy of reactants is equal to the energy of products? No, no. Cannot be equal. Cannot be equal. Reactant energy and product energy cannot be equal because endothermic reaction means reactant convert into product. Some amount of heat is absorbed to the system. Therefore, product energy level is greater than reactant energy level. I think you can remember. The energy of reactant is less than the energy of product. Yes, yes, yes. Product energy is greater. Again read, the energy of reactant less than the energy of product. Yes, because I already explained. Now think this is a reactant convert into product. Reactant, if they have 10 joule, 2 joules absorbed from the environment, then product contain 12 joules. Product energy level is 12, it is greater. The energy of reactant is less than, yes, reactant less than the energy of product, yes. The energy of reactant is greater than, it is exothermic reaction. That's about exothermic. It is exothermic reaction. It is wrong. The answer number 4. Who correct this final answer? Final question? Raise hand. Who correct this final one? Okay. 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 Who correct this final question? Correct. 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 Yeah, all are correct. Very good. Yes. Okay. Okay, I'm going to wind up today class now because we have 2025 final class now. 9 to 12. Okay, then we discussed the remaining part of the paper, the essay question. No, essay, only one structured essay. Tomorrow, 9 to 10 p.m. 9 to 10 p.m. Don't forget the time, 9 to 10. And we start the revision first introduction seminar day after tomorrow, 8:30 a.m. morning. Okay, goodbye, good night, tomorrow and day after tomorrow.